Welcome back to a new episode of The Technology Addicts, the podcast from Avnet Abacus. It's great to have you with us. The design of infrastructure solutions for EV charging is affected by a multitude of developments, among them new battery technologies, fast charging systems, innovative connectivity applications, and an ever-increasing degree of vehicle automation. Other factors impacting future charging infrastructure include energy supply, political decisions, and global trends. Today, we'll be discussing which trends are most important for charging station manufacturers with Bevan Brody. Bevan is Business Development Manager at Avnet Embedded. Hi, Bevan.
Good morning. Great to be back.
Bevan, what are the most important technologies and trends in terms of future EV charging infrastructure solutions?
The AI technology as a definite technology that's being implemented and quite relevant within the EV charging space. As the technology with AI has become smaller, cheaper, and more readily available, it allows us to assist the customers in adding the AI technology into their EV chargers. And this opens up a plethora of additional value-added services that they can offer to both the operators and to the end user, such as security and remote monitoring, coupled with technology such as facial recognition, vehicle recognition, and also power monitoring to feed back to the grid. This can all be done very quickly and efficiently at the edge with very small devices around the AI inferencing models and fed back to the cloud to be monitored.
Which technologies are key to expanding charging infrastructure in a quick and sustainable way?
So with the ever expanding and growing speed of new technologies, we still face one key issue. Battery technologies are still weak in terms of their power versus range and performance for most people. A range of 200 to 300 miles may very well suit the average commuter, but for longer distance requirements, the infrastructure needs to be rolled out faster with quick charging systems, allowing those people to rapidly charge their vehicles versus having a short range. Many people still look at PHEVs due to range anxiety, but with fast charging coupled with smaller, more efficient batteries due to come out in due time, further range will become the norm. Until such a time, we still face challenges in expanding our network of chargers to meet the demand of recharging EV vehicles. But that being said, there are many niche companies thinking outside the box. For example, customers utilize a mixture of grid power and battery backup by the chargers, allowing to quickly and efficiently boost the charge power to these vehicles, and also including a combination of different power sources, including some green energy. These niche ideas are key to accelerating the infrastructure and sustaining it through ingenuity and advancements in technologies.
And Bevan, you represent Avnet Embedded. You're a business development manager. What support can Avnet Embedded offer to manufacturers?
So Avnet Embedded is an industry-leading technology manufacturer and partner committed to high-quality, cutting-edge, cost-effective solutions for the EV charging vertical market. To some of our customers, we are simply a supplier, but to many, we are actually a technology partner. Our ethos always remains customer-focused, and in times where risk mitigation and local manufacturing have escalated the desire to work within local regions, ultimately saving our customers time, resource, and cost, we are at the forefront of the EV charging movement. Our vast expertise in the professional consumer EV charging space allows us to help our customers launch their products to market quickly, efficiently, and professionally. And we achieve this by utilizing our core technologies and expertise with building blocks. And this assists us in delivering a concept to customer rapidly. And further value add can also be found through a vast capability in software offerings, connectivity, and also interconnect passive and electromechanical through our other business units.
In the future, the charging of electric heavy goods vehicles, HGVs, is also likely to play an important role. How will that impact the technology used in charging stations, Bevan?
So we rely heavily on our HGV drivers to supply essential goods, food process, clothing, etc. And without these HGVs, we would never have the convenience and variety of produce we have become accustomed to today. But as you say, how is this going to impact the EV era? HGVs are heavy producers of greenhouse gases, and with ever-increasing costs in fossil fuels, we are seeing an impact through the chain to the cost of our goods. Many companies have started to move their fleets of vans to EVs, and we are seeing the trend with buses, trains, and of course HGVs. There's currently over 6.2 million HGVs in the EU, and these vehicles account for 73.1% of all freight within the European Union. By moving to EV, the HGVs will dramatically reduce the cost of our goods in years to come, but more importantly, will reduce our carbon emissions 100-fold. Ultimately, when we will need the infrastructure to charge these HGVs, of which technology is fairly similar. However, we will need bigger batteries with more storage and faster chargers for these vehicles, in particular the heavier long-distance HGVs. This will be one major driving factor in faster chargers with higher voltage delivery and bigger battery storage. And many HGV manufacturers, as well as plant machinery manufacturers, are investing in alternative technologies such as EV, coupled with green technology, and also delivering their own infrastructure of EV charging to alleviate the requirements on the public sort of EV charging infrastructure. And I believe this will deliver exciting new technologies to the EV industry, but only time will tell. And I think we've still got a little way to go until HGVs are all EV.
One particularly alluring prospect is the opportunity of pairing electric vehicle charging with renewable energy sources. Is it thinkable or even possible to combine photovoltaic energy generation and EV charging?
So yes, renewable energy is 100% the way forward in the EV era. We have a struggling grid system with connecting technologies driving demand on our power supplies. And when we consider the vast amount of electric vehicles consuming vast quantities of energy, alongside our current daily power needs, we have to consider alternative sources to keep our vehicles moving. Several companies are investing in niche ideas such as photovoltaics, solar, to battery storage, which in turn charges the vehicles. And in fact, some manufacturers are going as far as creating EV vehicles may never require charging due to nano solar technology embedded within the vehicle's paintwork and on their glass and roof. So it sounds like stuff of the future, but it is happening as we speak. What if we could harness the power of nature, whether it's sun, wind, or oceanic currents, to keep our vehicles charged and moving in a perpetual cycle without burning fossil fuels? It is an ideal scenario to meet in this increasing demand on power through our current grid infrastructure.
Super exciting, Bevan. So what does this mean in terms of technology if we focus first on the vehicle and then move to the charging stations?
Well, we should not negate the fact that these types of technologies are available today, but there is still substantial investigations and trials and testing of all possibly renewable energy sources for charging stations. Basically, we will see our chargers become smaller, easier, and faster to deploy, with rapid charging from ultimately green and renewable types of energy resources. But this is only achievable when all manufacturers are prompted to make this happen within their local government's guidance to a greener option for energy. In addition, storage of this power will be essential to holding that renewable energy in a location where it can then be fed back to the vehicle chargers. This will help reduce the complexity of the charger network by keeping power on demand in locations away from the chargers. E.g., a shipping container could be deployed rapidly to an event, housing batteries, power circuitry, connectivity, cooling systems, etc., coupled with wind and solar or similar technology to house that power and deliver it on demand. This would then feed an array of extension leads in effect. This is being trialed by a few of our customers in the EV space, and they believe it will revolutionize the smaller short-term requirements for the EV infrastructure, such as events like concerts, etc., but equally become more efficient in time so that they'll be able to install a charger with a zero reliance on the grid.
Bevan, I keep hearing and reading about smart charging stations. They seem to be particularly in vogue. What is a smart charging station and what are their advantages?
So smart charging is a common term that refers to a various set of functions of a charging station that make the charging process easier, cheaper, and more efficient. So smart charging works by controlling the power, timing, and direction of an individual charging session and takes into account the customer and vehicle needs, infrastructure limitations, renewable energy generation, electric costs, grid conditions, and ancillary grid service markets. For example, smart chargers have the ability to utilize load balancing. In smart charging terms, load balancing refers to the distribution of power between charging stations for those operating multiple charging stations at a specific location, or for those operating a single charging station with dual sockets. Operating a charging station requires a power source, e.g. a building or a supermarket, to carry the cumulative sum of the total capacity of these charging stations. With load balancing, it distributes the available capacity proportionately over all the active charging stations. In doing so, optimal charging is provided to all electric vehicles at that location within the limits of the charging station's capacity. A sample scenario, if a parking facility has a power source and a maximum of, let's say, 30 kilowatts available for 5 charging ports, and 4 vehicles start to charge at 7.4, utilizing the full capacity of power available. When the 5th vehicle joins, there's not enough power to charge all those vehicles at 7.4 kilowatts. This is where the load balancing comes in and distributes the power equally, so each vehicle can then in turn start charging at 6 kilowatts. And in addition to these features, many smart charging stations require data to be accumulated at the edge and sent up to the cloud for analytical feedback to the operator. By utilizing smart charging stations, we can now share this data amongst the chargers, and the data is then sent to the cloud as opposed to multiple non-smart chargers that have a dedicated modem each. And equally, this allows operators to monitor the chargers for predictive maintenance, saving downtime for when the systems do fail for whatever reason. And it all basically boils down to cheaper, greener, and more efficient charging for the consumers who use these systems.
What should people developing these systems pay attention to if they want to develop a future-proof, smart solution? Are there any functionalities and features, Bevan, that are must-haves?
So it's quite a difficult one to answer, as many manufacturers are trying to differentiate themselves by having alternative offerings, such as paid signage or contactless payments. But nevertheless, good points to consider are things like OCPP, which is a definite must for EV charger manufacturers to consider. So OCPP is the Open Charge Point Protocol, and it's a communication standard for EV charging stations and charge point management systems developed by the Open Charge Point Alliance. And the OCPP allows them to integrate freely with one another and provide robust features to all stakeholders in the EV charging supply chain. But equally, it also enables companies to monitor their charging stations in real time. This leads to upwards of 80% decrease in on-premises maintenance and can be achieved with remote charge point operators. In addition to this, they should also consider things like future-proofing their communications. So, for example, 3G is being switched off in the US and 4G is becoming the de facto minimum standard. So they should always consider forward-proofing their technologies for communications such as 5G and eventually 6G, moving from Wi-Fi 5 to having Wi-Fi 6 availability, as these are the backbone of the edge of data analytics, the payment systems, and the remote maintenance and manageability. And by implementing a modular wireless design from the early stages, this will allow the manufacturers to easily upgrade, reducing the cost of chip down design and being able to move with new technology. Another takeaway for future-proofing and flexibility is what we often offer our customers options to move from x86 to RISC to AMD off the same building blocks. So we could take a standard compute module, design a carrier board for a customer specification, but with minimal impact to hardware and software, we can switch between different CPU technologies. In these current times of supply chain uncertainty, we can help ease that transition to available silicon at the drop of a hat. And this allows the customer to scale and also have forward compatibility based on new technologies that come out by changing the module to match the required use case.
Charging stations that transmit the electricity to the vehicle via cables and connectors are commonplace. What about alternative technologies like inductive charging or systems like overhead charging?
So funny enough, I was actually speaking to a colleague of mine when I was in Germany a couple of weeks ago, and they reside in Italy. And we were discussing conductive charging for EV vehicles, and we discussed the basis of conductive charging. Has been around for some years. However, it's never really been cost-effective or fast enough for consumer use. Generally, it was resigned to the rail, bus, or heavy goods vehicle type applications where charge time was not as much of a priority as, let's say, you or I would require when we charge our vehicles. My colleague then proceeded to enlighten me on how Italy have introduced an extra lane on their smart motorways, specifically for conductive vehicle charging. And an Israeli company is specialized in inductive charging of electric vehicles, will provide its technologies to two vehicle and bus manufacturers who will then test it on Brescia in Italy as part of the Arena of the Future project. And basically, this will allow vehicles to use the lane down the motorway and conductively charge their vehicles as they're on the move. The user will then be billed by ANPR technology against the number plate due to the amount of charge consumption, the time dwell, and also it will most likely be on the distance. Likewise, overhead bays would be an option too in reversing the charging system from the ground to above the vehicle. But this will need to happen quite widely in terms of being implemented. And we also need to consider investment from vehicle manufacturers to standardize on conductive or inductive charging standards for all vehicles. Also, if we couple this with the infrastructure intensive impact to implement such technologies, we also need to consider things like the size of the infrastructure layout. And also another major consideration would be historic roads, European roads that are historic. There would need to be substantial effort to implement that in a timely and efficient manner that doesn't damage any of the historic infrastructure. So to summarize, wireless charging will happen, but I think we've got some way to go before we're going to see that type of technology being widely used.
Another important aspect is the authentication of the vehicle or user at the charging station. Which solution will win out in terms of authentication? Will it be authentication by smartphone app or plug and charge or an RFID card? What's your take on this, Bevan?
So all the different operators have multiple ways of doing it, but we have seen some real life case studies. So all of the technologies you just mentioned are utilized today. So let's say you go up to a charger, you can either use your mobile phone to authenticate once you've got your vehicle plugged in, because you'll have a pre-registered account. You could use an RFID card or tag. You could do an on the go as a guest login with your credit card or your debit card. You could even have the vehicle talking to the charger so it knows that vehicle belongs to you. It knows your bank account details, and it will automatically do that on the fly. But another technology that we've been implementing in Taiwan with one of our partners is automatic number plate recognition for multiple reasons, coupled with some AI camera technology. What this will allow you to do is drive up to the charge point. It'll automatically read your number plate. It'll know who the vehicle belongs to, the type of vehicle. It'll even work with the vehicle's onboard diagnostics and tell the charger how long it's going to need to charge for, how much current it's going to need. But coupled with that, there's also facial recognition cameras with AI. So as a sub-layer of security, the camera will recognize you as a predefined face coupled to that vehicle. So nobody else could, for example, steal your vehicle and then try and charge it. It would also take that as authentication for the payment, but also has behavioral analysis. So if the person was intoxicated or any other potential issues, the AI technology would record all the evidence, the number plate, the dwell time, and also alert the relevant authorities. So I think this type of technology where it's fully automated will become the norm. But for now, I think we will continue to see a plethora of different options, whether that's RFID, mobile phone apps, or tap and pay.
Bevan, now we've touched on many interesting and sensible functions and features of charging stations. Do they have to offer all of them?
That's a very interesting question. A lot of EV charger manufacturers or operators are trying to differentiate from each other by having different technologies or different value adds. I think as long as they all have the bare essentials, like the OCPP, for example, and various payment options to meet a wide, diverse market, then I think there is no requirement for everybody to standardize on all the different options. I think having the different options would be a value add to the user. But again, we have to consider that some of these EV chargers are for specific applications, let's say, example, street side charging, where it would seem more important to have something like digital signage for revenue stream. Whereas if it's in an office environment or a workplace environment, that's less of a requirement because they're coming to a place of work to plug their vehicle in and go inside to work. So There are different technologies, but I think the core technologies are pretty much what we've covered today. Connectivity, OCPP, payments would all be sort of the ones that I think should be a standard within all EV chargers. The rest would be down to the manufacturer to differentiate themselves from the competition.
And what role does the flexibility of computers and human-machine interface technologies that Avnet Embedded offers or can offer play?
The role in which technology and compute embedded technology plays within the EV charging infrastructure is extremely important. All of the technologies within EV charging are basically around power. But if we consider all the other requirements, such as remote management, security, payment systems, all of these types of technologies are all bundled through our compute and embedded platforms, coupled with human-machine interface. And we should also consider certain demographics where there may be slightly hard of hearing or have other disabilities. The technology can help that demographic use the EV chargers with a bit more ease. So I think it's highly important that we are now in the most connected era we've ever been in the human industry. So I think now is when this technology helps expand the network, make it more efficient, and ultimately deliver a seamless infrastructure experience for the end user.
With all these developments, how could concerns around rapid obsolescence be addressed?
So obsolescence is a very key issue at the moment, particularly with the impact that we've had from COVID-19 over the last couple of years. Supply chain of silicon coupled with dwindling workforce working from home and the demand for increased electronic sales on the consumer basis has driven us to a difficult situation in supply chain. One of the key things that Avnet Embedded works with is all of our partners on the silicon basis, and we only work with long life cycle embedded product, or what we call an embedded roadmap. So all of our silicon and our major key components on all of our products are anywhere between 5 and 15 years availability. We will always work with our customers to make sure that we have a lockdown BOM with the longest period of time of availability to market for the customer's requirements. We also work very closely with our customers so that when components do become obsolete or are due to become obsolete, we release end-of-life notification at least 12 months prior. And we then work very closely with the customer to find an alternative solution, giving them forward compatibility for X years from there on in. So obsolescence is a key discussion point whenever we speak to any of our customers, specifically in something like EV charging. If they have to go and change components or retrofit components to a very large estate of chargers, that has a very large financial impact on our customer. So it is very much at the forefront of our minds, and we work very closely to make sure that we have minimal impact when we work in this type of application for obsolescence.
I'm absolutely amazed by the amount of things that are happening in the EV charging space. It's super impressive. Bevan, thank you for sharing the insights with us today. Dear listeners, if you'd like to get in touch with Bevan, you can reach out to him and you'll find all the contact information on this campaign and about Bevan Brody in the show notes. Please feel free to subscribe to our podcast, The Technology Addicts, on your favorite podcasting platform. And Bevan, once more, thank you for joining the podcast and for all the insights you shared with us today.
Thank you so much for having me.